Now we're going to move on to sorted lists. And in this program, we're going to create two methods. One method creates a sorted list. So here we are using it here. It's going to have no parameter, and it is going to return the head of this sorted list. We can verify then that our list is sorted. Here is our print line to say this is the initial list and our call to the print list. And then 3 times we're going to ask our user for an integer. We're going to collect the integer. We're going to pass it to a method that inserts this integer, makes a node with the integer, inserts it into this list, and returns the new list. Once we exit this for loop here, we then print final list, and we'll print out our list and verify that indeed it is sorted. So this is our logic for main. Now, many students at this point would go ahead and create this sorted list, write this method, the one that we call on line 15, and then write the method, the one that we call on line 23, and run the program and cross their fingers and hope for the best. In some cases it will work, and in other cases there will be a mess, and that then needs to be debugged. Let's think about the easier way to do this. I always suggest to students that you create one method at a time. Verify that that method works, and then you can move on to the second one. So having said that, most people will say, okay, so let's create the one on line 15 first, and then we'll do the next one. But let's think about this. In order to create a sorted list, I am going to start out with an empty list and then insert into that list, keeping it sorted, which is the exact same thing that this method on line 23 will do. The one on line 23 does it one time, takes this number, makes a node out of it, and puts it into this list in the correct place. The one on line 15 does it multiple times until I have my list created. So what we need to do is write the one for line 23 first. Okay, you say, however, I need a list. I need a list in order to insert into it. What I can do is create a list in place of calling this method, create myself right up here a sorted list very easily. I'm going to erase this later. Don't ever be scared of writing code that you then delete. So I'm going to make the head of my list a node, and I'm going to put the number 10 in there. Then I'll make another one, temp equals new node. I'll put a 20 in it. I can make another one, temp2, put a 30 in it. Now all I have to do is hook these all up. So head.next is temp, and temp.next is temp2. And at this point, we hope that we have a sorted list. Quick check. Comment all that out. Run it. And then we have our initial list 10, 20, 30. Okay, so now I've got a list. Admittedly, I'm going to delete that code, but it only took me a minute to write it. It's no big deal. And then I will be able to write my method in place of these 3 lines of code. So now I've got a short list and it is sorted. Now I need to write my next piece, uncomment that, and write this insert into sorted list method. So in the interest of time, I have written it. Let's just talk about it. We have a pointer called current, which we start out at null. We worry first about the head being null. We have no list. If we have no list, then make a new node, put n into it, and make head point to it, and I'm done. Head is pointing to our new node, and that's the only thing in the list. Else. So now my list is not empty. I set current to point to head, and I get the item from current. Initially it would be head's item, which I have to cast as an int. So now I'm going to look at n. If n is less than current item, if n is less than the item in head, I have to prepend. I have to add to the front. And the easier way to do that is to make myself a new node, called it temp, and I make the next in temp point to head, and then head equals temp. I've made my new node called temp. I make temp's next point to head, and then I make head point to temp and no longer point here, and I am done. Else. And now I have a while loop. The entire while loop is here. And I will go through, I'll go round and around this loop, moving current along. You remember it started out here at head, moving it along as long as this is true. This is a compound Boolean, so it is true if both sides of this ampersand are true. And it is important that we get this order correct. While current.next is not null, and this. And the reason that we need the order to be correct, in other words, current.next is not null on the left hand side of the ampersand and not the right, is that with this double ampersand, if the left is false, the right will not be evaluated. In other words, if current.next is null, it will not try to evaluate whether n is bigger than current.next.item. We don't want to try to evaluate that, because if current.next is null, current.next.item does not exist. And to ask whether n is bigger than something that doesn't exist, you will get an execution error. So we need to be careful here that we in fact stop if current.next is null. And I'll talk about that in a minute. Let's assume right now that current.next is not null as I go through my list, and I stop when the right-hand side becomes false. In other words, when n is less than or equal to the next item. So I start out my current at head, and I go along this list and I stop. Let's imagine I stop here. Why did I stop? I will stop because n is less than or equal to, let's just say less than, it's just faster to say less than current.next.item. If it's equal to, I'm going to have two equal things in my list. It doesn't much matter which one comes before the other because they're both the same. So if n is less than current.next.item, if the number I'm trying to put in is less than, let's imagine these are hooked up here, current.next.item, this number here, if the thing I'm trying to put in is less than this number here, then I have found the place to put it, my new number. I'm going to make a node out of it. I'm going to put it in a node, and I'm going to insert that node between current and current.next. I have found the place where I want to insert my new node. Well, first I've got to make it. So when I make it, I'm going to make a new node. I'm going to put the n in it, my integer in it, and I'm going to set its next to be current.next. So I'm going to make a temp, and I'm going to make a new node, put my n in it, and its next is going to point to currents.next. Current.next is this node, its next is going to point here, and this guy here is gone. So temp is this fellow, my new node, and temp's next is going to point to currents next. Temp's next is going to point to currents next. I did that in the constructor. And now current.next is temp. So current.next no longer points here, it's going to point here. And I can get rid of that. And you can see that this new node was put in between current and current.next. The only other time that you would get out of this while loop is if current.next is null. So when current.next is null, let's make sure that these two lines of code still work. So if current.next is null, let's just make ourselves a new list here. So this would be head. I'm going to start out current. I'm going to move current along, looking for the place to insert my new node. But once I get here, current.next is null. So when current.next is null, I'm at the end of my list. So the other time I would exit this while loop is when current.next is null, in other words, the end of my list. So let's see what happens here. I make temp a new node, I put my integer in it, and its next points to current next. So if I make myself a new node, and this is now my temp, and its next points to currents.next. Well, currents next is null, so its next is also null. And what was the next line? Current.next is temp. Current.next is temp. So I did manage to put this new node on the end of my list. So this works if I exit my while loop because the left side of my Boolean is false, or if my right side is false. But be real careful here that you put this on your left hand side of your Boolean, so that if your current.next is null, you make no attempt to find out what its item is. Okay, so let's run this. We put 10, 20, 30 into our initial list, and here we're going to add 3 integers. We should add 1 before the beginning, so we have to prepend, we have to test that append is working, and test that something in the middle is working. So I'm going to suggest 5 to test the prepend, 35 to test the append, and 25 to test the middle. So here is our original. We'll put a 5 in to test the prepend, a 40 maybe to test the append, and a 25 to test something in the middle. And here is my final list with the 5, 10, 20, 25, 30, and 40, nicely sorted. So we know that our insert into sorted list works. We just have to use it now. We can eliminate this. Now I have to write create sorted list. Going to return a node. So here we are calling our create sorted list, which will return the head, which we will print out and then ask our user for 3 more numbers and print out our final list. In our create sorted list, we're going to start out head as null, and then I'm just going to put 5 things in a list. So here is our for loop, ask for an integer, get the integer from the keyboard, and then call insert into sorted list with the head and that number that returns the head. And then we'll do that 5 times and put 5 numbers into our list. So let's run it. Um, 20, 24, 67, 3, -2, and we can see here that we have got them in sorted order. And now add some more. 45, -5, something bigger than 67, 90, and something in the middle. All right, and here is my final list, and we can verify that it is indeed sorted. So again, we did the insert into sorted list first so that we could then verify that that worked, and then we did our create sorted list because we're going to use insert into sorted list within our create sorted list method. Good.